what should be the role of our institutions? Our institution should tailor composition, engineer composition, put the appropriate amount of various material, making tea, it is engineering. If you put the sugar, the milk and the tea in appropriate amounts, you are a good engineer of tea. If you imbalance those, then the tea will not be better. The same thing is in the modern engineering, that you design and tailor composition about required by the products. Process them in a way that you suppress the negative properties and enhance the positive properties. Suppress the negative properties and enhance the positive properties. And thus, engineering of material is the gateway to optimize the utilization, optimum utilization of your resources. This is a very old image. This is the sand sea. Will anybody buy it for 5 rupees 50 kg? But when you design its composition, you fire it. If you are illiterate, you can make marble balls from it. Educated, you can transform it into car screens. You can transform it into fiber optics. You can make telescopes and microscopes and different things with it. So this is the difference between knowledge and no knowledge. If you didn't utilize this room, you didn't learn the education required for your better life, for your better world, then you will make those things. And if you are intelligent enough, then you can transform it into fiber optics, and you will buy a few grams of it for several thousand rupees. This is the optimum utilization of resource. So what it is, let me go back to that quartz, feldspar and clay model. That where does come physics in it? Where does come chemistry in it? Clay is hydrous aluminosilicate. When it is heated up to 570 degrees, it dehydroxylates. It loses the crystalline structure. It becomes amorphous at 570 nearby degrees centigrade. When you heat it up to 900 degrees, above 900 degrees, it transforms into aluminum silicate phase, which is called molite. And molite is the high temperature resistant phase. It doesn't melt at high temperatures. So you call it temperature resistant phase. The quartz transforms from alpha quartz to beta quartz in about 530 or 540. At 1250, it starts melting when it is in contact with alkalis. When it is not in contact with the alkalis, then its melting temperature is above 1600. Now think scientifically, why the vicinity of alkalis decreases the temperature? What is atom? Atom has electrons and protons in it. When you put an alkali near the quartz atom, it pulls the electrons because alkalis have positive or cationic nuclei. They attract the electron. So partially it is attracted by the nucleus of the quartz, and partially the heat relaxes it. So the melting is what is melting? Melting is the breaking of the bonds. Breaking of the bonds they can. So githeta sarana ajikele bonds matigi nodara priuzi ororo pakata bani raji o melki. So in a chemical reaction, you are actually breaking the bonds. And when an alkali nucleus is near the quartz atoms, the electrons are partially pulled by the alkali nuclei and partially relaxed by the heat. That is why its temperature drops from above 1600 to 1250. This is the science which is used for engineering, because if you prepare a product at 1600 degrees centigrade, you raise the temperature of the furnace to 1600 degrees centigrade, it will, for example, cost 10,000 rupees. But if your material, you can make it at 1250 degrees centigrade, its cost will be 5,000 rupees. So economic variation comes from science. When you decrease the process temperature, you decrease the cost of the production. And that is the economic bit in your science. Similarly, the feldspar has melting about 900 to 950 or 1000 at maximum. There are different types of feldspar. Feldspar are basically low melting aluminosilicate phases. So you bring them together, you transform them into porcelain. Now, what do you do in telecommunication devices?